let's continue with section 7.3, okay, on page 180, okay, on classification trees and regression trees. Mostly the examples are all classification trees, okay, with a few regression trees probably mentioned in SOA exam questions. Okay, so first part here tries to tell you that there are many different kinds of algorithms to generate classification or regression trees. Okay, so more or less I think some classify into various generations. I don't think the generation really matters. Okay, so the one which is actually shown in detail in this course is actually the ID tree algorithm for generating trees. Later on we'll see what is its disadvantage. The R software actually uses two packages, the tree and R part, right, which stands for recursive partitioning, actually uses the algorithm from CART, okay, which stands for classification and regression trees, okay, and there are also various others, okay. C4.5 seems to be an improvement of ID3, which is not actually mentioned here. And Law, an expert in decision tree algorithms, okay, has actually developed a few algorithms for generating trees, but okay, excuse me, fact, quest, and guide, right? But he did not release any implementation details of his algorithm. So we can actually download his binary executable files to run on our computer and generate the tree, but how the thing actually works, it's not really shown. Okay, probably the philosophy could be found, of the implementation could be found in his research paper. Okay, random forests, etc. Okay, these kind of things have implement the construction of the decision trees together with ensemble methods, okay, which we'll see later. Okay, so this is what we need to know in order to understand why it took me so long to write up this topic on decision tree, because there are too many things. Okay, and basically this topic only touch very little, okay, on ID3, okay, and even less, okay, on others. And C4.5, if you recall from the previous videos, is actually more or less replaced by a commercial version, which is C5.0. Okay, in R there is an implementation C50. Okay, so as I mentioned, right, okay, the thing we'll discuss here is actually the ID3 algorithm. So what's so bad about this algorithm is it basically only deals with discrete features, meaning all our input data needs to be categorical. Okay, it doesn't actually handle numeric features. Later on, some of you might find some numerical features but I'll mention why it's actually not truly numeric. Okay, and the splitting is actually multi-category. Okay, as we'll see towards a later discussion, okay, in the tutorial and examples discussion. Okay, the bad thing about ID tree is that the tree generated are normally short. And why? Why is it short? Because it depends on how many features we have. If we have x1 until xp, right, it will be at most up until p of them only. Okay, so because we branch out a lot, so it's going to be shorter, but it's going to be wider. Why is it wider? Because for each category, if we have a lot of different subcategory in a particular feature, then we will have many branches. Okay, we'll mention this again when we go to the tutorial and exercises. And bad thing about this is basically the algorithm does not put in any pruning. Okay, so the same mathematician who develop this algorithm actually proposed C4.5 to improve on this. Okay, but in C4.5 and CAD, okay, they start to perform binary splitting instead of using multi-category splitting. And okay, instead of the earlier information gain, okay, which is mentioned in section 7.2 being used, okay, the gain ratio and also Gini impurity index, okay, in section 7.2 I mostly just call it Gini index, is are being used. Okay, so you will find that basically the examples, tutorial questions, and final exam questions more or less just work around ID tree algorithm. Okay, so I'm not going to go through all the examples. I'll put it slightly later. Okay, I just hope that you know the overall picture of what is actually going on. So these are just examples. Later we will discuss. Okay, and for those of you who really want to see how ID tree is actually being implemented, you can actually search on the internet on the ID tree for classification using data tree implementation in R. Okay, so this website actually provides such an implementation, and we actually just construct the data frame and pass it to the algorithm given here to, okay, for example from example 7.3.2, right, okay, it will just generate the ID tree for us. Okay, and if we apply to the playing tennis data, which is given in example 7.1.1, you should be able to get the text representation, text representation of the tree, which is shown earlier on. Okay, so I try to gather some information on things related to C4.5 as mentioned, right? Okay, ID3 cannot handle numeric data, okay, by default. So the C4.5 okay, which is I think the developer of this algorithm actually built his own company, okay, request, and just upload the very basic implementation of C4.5 on his website. Okay, but of course he developed something even more advanced, which is the C5 or C5.0. Okay, his website actually provides the comparisons between this C5.0 and C4.5 there. Okay, the other thing which we are going to use in our practical class is the C card. Okay, it's actually used in the tree package and also the R part package. Tree is not as advanced as R part. Okay, so I just put up the C4.5 algorithm down to the next page. Okay, which it's used divide and conquer. Divide and conquer just basically means okay, breaking down the problem into sub problems. Okay, so you can see that if all the cases belong to the same class, or this thing is small, the tree is a leaf labeled with the most frequent class. Okay, well, I think unless we implement it, otherwise it will take a long time to digest it, so I'm not going to go into it. Okay, so the other kinds of algorithm, I think trait is mentioned earlier. Okay, and this thing probably can also be found on the internet. It's based on slightly different measures. So the point of all this is to tell us that there are many different algorithms around. So we should try the most recent algorithms, but shouldn't throw away the older algorithms, because some of them are still useful for the simpler problems. Okay, so finally we put a SOA exam question example here. Okay, in which a regression tree is actually constructed for us. Okay, why is it a regression tree? It's a regression tree because the output, you can find that all of them are numerical instead of categorical. Okay, so this is a regression tree. Okay, and we are asked of questions like consider three autos. Okay, age in category 1 and vehicle age 4. So we are asked to do the ranking based on the decision tree. So the age in category 1, so age category 1 basically means what? When we start from the top, okay, I just mentioned on how to perform prediction once a tree is constructed. So why did I mention so many trees? And then it seems like we don't really need to know what is going on behind the algorithm. The main reason is if someone provides us the algorithm, we can just feed in to it and use it to generate a tree, and then we just need to look at the tree. So how the tree is generated in the end doesn't really matter as long as the tree is usable, right? Okay, it's just like how should I put it? It's just like, okay, we drive cars. How many of us actually need to know how the car is constructed? We don't. Okay, we only want to know, is the quality good? Okay, so basically in the end we just need to roughly know, okay, there are many different algorithms, so they generate different decision trees. Okay, and so in the end, what we will be doing to how would we would decide whether to use the decision tree or not depends on how good is the decision tree. Is the decision tree logical or not? Okay, so that is our key concern. Okay, so that's why I hope that you need to know that there are many different algorithms, and we can just use them to generate. So that's why here you find that, oh, a decision tree, okay, which is for regression problem is given, and then we need to know how to use it. Okay, the key thing to remember for decision tree is the generation of decision tree. Anything that goes to the left hand side, okay, like this one, is going to be yes, and anything goes to the right hand side is going to be a no in the note. Of course, the construction of this thing is slightly different. It just puts the condition of yes and no straight away. So okay, let's look at the first one. So auto category 1, so should it go to left or right? Of course it should be going to the right, okay, because the age category here, you can see age cat is 1, so it's less than 1, so straight away our output is 8.146. So I mean the answer is already given, so you can just see it here. Okay, I hope my explanation can tell you how you can obtain the answer for the second one and the third one based on the decision tree, or I mean the regression tree. So okay, next is in the construction of classification trees and regression trees. Okay, the main difference is because one is a numeric value, the other one is nominal or categorical data. So the main difference is like what you learn in statistics. Okay, point set 1. It's going to be a difference of mode and average, right? Okay, when we have multiple output. Okay, so section 7.4 is not very important for tests or solving tutorial question problems or final exams. It's but it's important in real world situation because when we put too many data, okay, and if we don't perform pruning, the tree would be very large. Okay, you can think of it as like a real tree. If we grow it, we put a lot of fertilizers. Okay, it will grow and grow and grow. Okay, if we don't actually trim it, sometimes it's too large, and we are driving under the tree. We might fear that suddenly it's falling down and cause some accident. Okay, so pruning the tree is actually cutting off some branches, okay, to make it safer. I mean, in predictive modeling terms, it means to reduce overfitting. Okay, so you can see past year exam questions. What you find that it's always asking this kind of basic conceptual questions, like a decision tree might be overfitted to the training set if the resulting tree is too complex. So what are the approaches that one could use to avoid building complex tree, right? Okay, so you'll find that, oh, it's pre-pruning, so before it grows you just cut it off. Post-pruning is like you grow it to be rather large, then after that you start looking back and going back and then start cutting it. Okay, so main difference between pre-pruning and post-pruning is you do it when you are growing it, or after you have grown it then you start to cut it down. okay, saving some memory, right? Okay, so pre and post. Okay, as the SOA exam question also more or less asks something similar. Okay, that's why I put it here. So let's determine which of the following statements concerning decision tree pruning is true. Recursive binary splitting method can lead to overfitting. Yes, of course. A tree with more splits tend to have lower variance. I maybe not, right? Okay, according to the solution here. Okay, when using the cost complexity pruning method, okay, alpha equals to 0 leads to a very large tree. Basically it's true, right? Okay, because alpha is multiplied with the cost complexity pruning. Basically alpha is multiplied to the size of the tree. So if alpha is 0 means okay, ignore the size of the tree. So the cost will take into account if alpha is not 0, right? Okay, let's say you put alpha equals to 1, okay, then you will see, oh, how come the cost is so high? Okay, we need to cut down on the tree size. Okay, so that's why answer is C, right? Only 1 and 3. Okay, 2 is false because additional split tends to increase variance due to adding to the complexity of the model, right? Okay, more complex model seems to have higher variance. Okay, so another past year exam question which we'll discuss only in the example section. Another thing we need to pay attention to is actually the complexity. Okay, because for all computer algorithms, we need to think of do we have enough memory, and how long does it run. Okay, the larger the data we fit in, okay, then we find that, oh, if for 3 it's going to be multiplied to log of n. Okay, if we have a balanced binary tree. If it's not balance, okay, then it might be quite high. Okay, these are some things we need to be aware of. So the key thing that we need to know about tree is conceptually is very nice, okay, but it has a serious problem of overfitting. Okay, that's why it's emphasized here. And in some situations, we need to perform dimensionality reduction. We have learned PCA earlier on. Okay, and there are other kinds of dimensionality reduction algorithms I should mention in the scikit-learn. Okay, and I think some of you have also performed your own feature selection during the assignment. Okay, so feature selection is another way to perform dimensionality reduction. Okay, we just need to be careful. Okay, some features useless, like, okay, what stuff ID, which I mentioned in class before. So those we can throw away. Okay, so for simpler problems, we should always visualize a tree. So these are some things we need to be careful. And of course, there are a lot of programming issues one need to consider, like do we want to save some memory by using single precision numbers instead of double precision numbers, and etc. and etc. Okay, so we'll break for 2 minutes and continue with ensemble methods.